Today, we're going to talk about adding vectors and momentum. First, we're going to talk about adding vectors. So, vectors help you find distance between two things. For example, if I'm at point A and I want to go to point B, we'll call this distance x. If I want to go from point B to point C, we'll call this distance y. But if I want to go from point C to point A, I use vectors to help me figure out that distance. In order to do this, you use the Pythagorean theorem, which is a squared, so this distance between here and here, equals b squared, the distance between here and here, equals c squared, which is this distance. And then, in order to find the angle, you just do the tan of a, which is this side, divided by b, which is this side, and it's the second tan on your calculator. We're also going to talk about the momentum and how that works. So, if Abraham Lincoln is driving his car and he hits this guy on accident, they will both continue forward at a slower rate. This is due to the conservation of momentum, which states that energy cannot be lost or gained. The speed of Abraham Lincoln's car slowed down as soon as he hit the other guy's car. That is due to the larger mass it gained. However, the potential energy has to the momentum has to be carried on as he hits the other person's car.
Alright, today we're going to be talking about acceleration. Pretty simple process. I'll just hop in my car here and we can get started. Alright, so acceleration is change in velocity over time, and change in velocity, if you don't already know, is your final velocity minus initial velocity. So if I start at rest and it takes me 5 seconds to get up to 10 meters per second, then my acceleration would be 2 meters per second squared. There's also a second part to it. If you're starting moving, so your initial velocity is a number, and you slow down to a stop, that's called deceleration. Because if you think about it numerically, your final velocity is 0, while your initial velocity is a given value, so you'll have a negative number for acceleration because you slow down to a stop. And that's pretty much all acceleration is about. Okay, the last thing we'll be talking about is force. So what is force? Force is the amount of newtons required to move an object either from a point of motion or from rest. So some things to think about are Newton's laws of motion. We're dealing with inertia, so I'll briefly explain what force is about. So I'll use a demonstration here. So I have my horse pulling this chariot, and so it's pulling it. So what the force would be to pull it is a function of the weight of the chariot with me on it and how fast it needs, the acceleration that it needs. So if I hop on here and the horse starts pulling, it's going to pull me like this, and it needs to be pulling at a certain force, or else I'm not going to be able to move. If it's only pulling with a little bit of force, I'm not going to move as fast. I'm only going to be going this fast. Or if it's not pulling with enough at all, I won't move at all because of the law of inertia. So force has to deal with push and pull of objects. You can see again the horse, the more force it uses, the faster I start to move, and that's pretty much what force is about. There's one other thing to think about when we're talking about force with your calculations. We have the sum of all the forces is equal to the mass times acceleration. It will be a very important equation because you'll use that anytime you're dealing with forces. F equals ma. So get that ingrained in your heads. Alright, bye now.